Okay, today's skill is to be able to graph a line given in standard form. So we've been working on writing the equation of a line given 2 points, or given the graph of a line. Now we're working the other direction. So given an equation in standard form, can you graph the line? So here's standard form. It's ax plus by equals c. You'll notice that the x and y terms are on one side of the equation and equal to a number. That's what c is on the right, on one of the sides. So you'll see the x and y terms grouped together. So some of the rules of a standard form: if you were asked to put an equation, a linear equation in standard form, we need the x and y on the same side of the equation. That's number one. It's right here. So x and y on the same side of the equation. The x term is positive, so we're going to make the x term positive. And we're going to have no fractions. So no fractions for a, b, or c. So if we have fractions, we're going to clear those out, and then we have a technique for doing that. Okay, so it says decide whether the equations are in standard form or not, and if not, why. So looking at these three rules, first question is number one in standard form? It's got x and y on the same side, so that's a check. The x term is positive. That's true in this case. The x term here is 5, which is positive, and there are no fractions. So this one checks out. That is in standard form. The second one on here, x and y are on the same side of the equation. The x term is positive. Right here we have a negative in front of the 2, so that one fails at rule number 2. We could rewrite that in such a way to put it in standard form, but right now it's not. The next one on here, it says 5x minus 3/4 y equals negative 2. The x and y are on the same side. The x term is positive here, but then we also want no fractions, and you can see right here we have a fraction, so that one does not fall into the category of standard form. All right. Next row, we have 1/3 x plus y equals 1. You could probably see that because we have that fraction of 1/3 here, it is not in standard form. The next one on there, it says y equals 5x minus 9. That one breaks down at rule number 1. We do not have x and y on the same side of the equation. We can move it over. Actually, it would be negative if I moved it over there, but then divide by negative 1. We could put it in standard form, but as is, it is not in standard form because this is not on the same side as the y. Same thing's happening here as well. We would need to move this 2y term over to the left side to put that in standard form. So the only one that's in standard form is this first one right here, according to the rules written up above. So one of the things you're going to be asked to do here is to write an equation in standard form. And once it's written in standard form, what we're going to do next is, let's move this out of the way, is find the x and y intercepts, and then from the x and y intercepts, graph the line. So you may be asked to actually write an equation in standard form. We're not on this one, though. So we're going to just, on this one, it's already in standard form. So we're just going to find the x and y intercepts. So find the x-intercept. Here's the process. We plug in 0 for y and solve for x, and that will give me the x-intercept. We'll list the x-intercept as a coordinate, so we'll know how to graph it when we get to that point. So here I would plug in 0 into the equation, this equation right here, in place of y. So I write 3x plus 4 times 0, I'm replacing y with 0, equals 24. It's equivalent to just covering up this term right here, this 4y term. It's like I'm scribbling it out, because 4 times 0 is just 0, and I'm left with the equation 3x equals 24. And so if I divide each side by 3, x equals 8. So my x-intercept here the place where the graph crosses the x-axis is located at 8, 0. And so I could plot that point, and that would be one of the 2 points that I need to graph the line up here. So once again, this is a linear function in standard form. 3x plus 4y equals 24 is in standard form, and the x-intercept is 8, 0. So if I want to find the y-intercept, kind of a similar process here. To find y-intercept, board's getting a little messed up here. So to find the y-intercept, we plug in, here goes again, plug in 0 for x. So we plug in 0 for x. Still messing up on me here. There it goes. Plug in 0 for x, and solve for y. So we're going to do that next. We're going to take and plug in 0 for x. 3 times 0 plus 4 times y equals 24. It's equivalent to going up here and just scribbling this out right here. Scribble out that 3x. And so if I go and do that, solving for y, 3 times 0 is 0, leaving me just 4y equals 24. And if I divide each side by 4, y equals 6. And so my y-intercept would be the coordinate 0, 6. So if I had those 2 points and I wanted to graph the line, I could say, okay, over here at 8, 0, right over here, let's call this 8, 0. I have one coordinate of the line, and then the other coordinate is up here at 0, 6, right here. 0, 6. And with those 2 points, I could graph my line. So that's finding the x and y intercepts of a linear equation in standard form. All right, here we go. On this one, problem number 2, we're going to go ahead and graph using the intercept. So I have x minus 2y equals -2. It's in standard form. To find the x-intercept, I'm going to abbreviate it here, x-intercept, I'm going to plug in 0 for y and solve for x. So it'll look like this. X minus 2 times 0 equals -2. 2 times 0 is 0, so I just get x equals -2. So my x-intercept is -2, 0. So on the graph, I'm going to go 2 left and 0 up and place a point there. So at x-intercept at -2, 0. So once again, we plug in 0 for y and then solve. To find the y-intercept, I'm going to abbreviate y-intercept. Make a spot here to write down the coordinate. I'm going to plug in 0 for x this time, so x gets replaced with 0. Y stays put. 0 minus 2y is minus 2y equals -2. If I divide each side by -2, I get y equals -2 divided by -2 is 1. And so my y-intercept is at 0, 1. So I go over to my graph, place a point at 0, 1. And if I have 2 points, the x and y intercepts, I can go ahead and draw my line through those 2 points, here and here. And there is the graph of my line, x minus 2y equals -2. All right, we haven't really talked officially about this. We've looked at slopes of horizontal and vertical lines, but we haven't really talked about the equation or graphing the line from the equation. Here we have what is the graph of each equation. It says y equals 3. Remember that equals is like the word is. And so this is saying y is 3 all the time. And so, for example, if my x coordinate were 0, my y coordinate would be 3. If my x-coordinate were, say, 2, my y-coordinate would be 3. If my x-coordinate were, say, -1, my y-coordinate would be 3. If my x-coordinate were -2, my y-coordinate would be 3. As a matter of fact, no matter what my x-coordinate is, y is 3 all the time. So that is the graph of y equals 3. When it comes to x equals 3, we could say, there it is. So this says x is 3 all the time. So x is 3 all the time. So let's go over to 3, 0, place a dot there. There's x equals 3. So if y were, say, 2, what would x be? Well, x would be 3. If y were -2, what would x be? Still, x is 3. If y is, say, -1, x is still 3. If y is +1, x is still 3. And so we have a vertical line. So x equals lines, we see our vertical lines, they have undefined slope. Y equals lines, our horizontal lines, they have a slope of 0. All right, problem number 4. It says we are going to transform this equation that is in slope-intercept form into standard form. Now, standard form, we're looking for the x and y to be on the same side. That was step 1. We also want x to be positive, and then we also don't want any fractions in it. So those are the 3 things we're going to try to do to transform this. So step 1 is to get x and y on the same side. Well, I can move this term over to the other side, add 3/7 x to each side. It cancels it out on the right and moves it over to the left. And I'm going to write the 3/7 x in front of the y. So I'm just moving or adding that 3/7 x over to the left-hand side is the way I think about it. So we're adding 3/7 x to each side. Now, I've accomplished 2 things here. I've done number 1 and I've done number 2. I've got x and y on the same side. I also have step number 2, or rule number 2, was that it needed to be positive. And this is, in fact, positive. So there's one more thing I need to take care of, and that is getting rid of that fraction 3/7 in front of the x. Now, in order to get rid of the 3/7 in front of the x, I need to clear out this 7 on the bottom. Well, one way to clear out that 7 on the bottom would be to multiply 3/7 x by 7. And so if I were to put parentheses around this and multiply this by 7, we'll see that the 7's will cancel out, leaving me with no more fraction. I just have the term 3x. Well, if I'm going to multiply that term by 7, the distributive property says that I can't just multiply that by 7. I've got to multiply each and every term on both sides of the equation by 7. So that would mean I have to multiply the y by 7, which doesn't introduce any fractions. It stays a whole number, just a different whole number. So it's 3x plus 7y. And on the other side, I have 5, and I also need to multiply the 5 by 7. So multiplying this entire equation through by 7 gives me the standard form 3x plus 7y equals 35. I have no more fractions. You can see I have x and y on the same side, and the number in front of x is positive.